Hi folks, welcome to another HPIN Academy training video. Today we're going to be doing a requested video which is on the ESBE diverter valve. There's been a few requests and as promised we will always try and do videos if you need them. So we'll be having a look at the diverter valve that comes with the Daikin kit. Now this comes with the cylinder guys, and it will also come with a few other little bits and bats in there. So we're going to do another video on the contactor kit which also comes with the cylinder in with the ESBE diverter valve and a cylinder sensor, but we'll do that on a separate video. Now the ESBE diverter valve can be fitted in 4 ways and we'll be going through those 4 ways in the video a little bit later on. We have talked about the simplified method in the level 2 training, so we'll have a look at that first and then we'll go through the other 3 ways and how to fit it and make sure that the ESBE valve is set up correctly. So the ESBE diverter valve is a fantastic piece of kit, and this comes with the Daikin cylinder, or if you have a third-party cylinder it will come in a separate box, so please make sure that you know where this is. The box is marked up with the labels EKUMBPART, and that's the name of the box that this will come in. It comes with the diverter valve itself, which comes in 4 main components. It comes with the contactor kit, which we will go through in another video, and it also comes with the cylinder sensor. And these parts you're going to need to fit into the system. In which case, the ESBE valve itself comes in 4 main components. So you get the body of the valve, which is this piece here. You get the head of the valve, which is separate. And then you get the little spindle, or as we call it, the castle, which interconnects the 2 together. From there, you do have to screw the body and head together. So we get this little screw to join the body and head. There are 4 ways that we can fit this valve, and we'll go through a few of the different scenarios for you. We'll start off with the simplistic way of fitting it and just give you a refresher on that, and then we will have a look at the other methods of fitting the ESBE diverter valve. So with the ESBE diverter valve and the simplistic way of fitting it, we said that on the valve itself there is a little triangle, a circle and a square. And always remember that the only thing that we cannot do is take the flow into the branch. The valve itself will only spin through 90 degrees. It doesn't spin through 180 degrees because, as with any air source heat pump, the unit will only do central heating or hot water. It won't do both at the same time. So we can't fit the flow into the branch. Remember, no flow into the O. But the simplistic method, as we've talked about it, there's a little square here and we've got square radiators, so that's for the heating. We've got a circle for your cylinder, and we've got a triangle, which is either an arrow pointing into it or it is the Daikin symbol, which is the flow into the valve. If you pipe this up in this way, then it means that you do not have to mess around with the head and change any jumpers inside of here. So it makes it much easier when you fit in the valve itself. So from there we get the little spindle, and on the spindle there are 2 lines that you need to know about. Now the first line goes all the way around the circumference of the spindle, or the castle as we call it. And this line is really important because if we're fitting it in this position, the line needs to be at the top. It must never be at the bottom close to the actual valve body itself. If you do that, when this goes on here, it won't sit down into position properly and it will just spin on the actual valve. So we're going to turn it round and we're going to have that line at the top. And very gently you need to place this on here, and we're going to turn it round until it drops into position. Now you may find in some places that it does click down and it actually sits on the valve and you think that might be it, and you can push it down a little way, but you can see that this spindle, this castle, is not all the way down to the black plastic shroud at the bottom here. That is not in the right place. If you have to use any force whatsoever, then that spindle is not in the right place on the actual valve itself. So we're going to lift it back up and we're going to turn it round until it comes to the right place and drops down as easily as that there. Now hopefully you can see that that is now all the way down to the black plastic piece without any force whatsoever. In which case that is now in the right place. Now that the spindle's in place, we need to think about setting that up. But to set it up, we need to have a think about the head itself. Now, when the head comes, this line on the knob on the dial of the head is in mid position out of the box. It doesn't come over to the left hand side or to the right hand side. It comes in mid position, and this is in between central heating and hot water. It might be that central heating is over here and it moves to hot water over onto this side. It might be that this is central heating and it moves over to here to hot water. At this point, it doesn't matter. Out of the box, all you need to know is that as standard, it comes with this red line in mid position, in between central heating and hot water. With that in mind, we need to look at another line on the castle, and we have a line right the way from the top to the bottom of the castle, in which case we need to now put that line in the same position as the head, which is in mid position. Now that would, as we say, be in between central heating and hot water, so we're very simply going to point this line in between circle and square, as shown now. There is a little nodule, there are 4 little nodules on here, and there's one perfectly in between central heating and hot water, in between circle and square. So we point that line to there, and we know that the inside of the body of the valve is now in mid position, so it matches the head. Once the body and the head are in the same position, we're going to fit these two together. Now, I talked about these 4 little nodules earlier on the actual valve body itself. And if I turn this upside down, you can see there are 4 little pins here, which are locator rings on the actual head itself. And these match up to the body. So we can fit this in any 90-degree angle whatsoever. If this head were to be fitted to the body in this orientation, then if the dial on the actual head itself were to move 45 degrees clockwise, then the castle would also spin 45 degrees clockwise. If we change the orientation, if this was to be fitted onto it this way, then actually if it spun 45 degrees clockwise back, this would still spin 45 degrees clockwise back to the original position. So it doesn't matter which way we fit the head to the body. The only thing that you need to know is that this has to go on at a 90-degree angle. And when we put the two together at any 90-degree angle, these will lock in place. So once they're locked in place, we're going to take the knob off the actual head itself, and you can see that we can put the screw straight through the center here. So if we put the screw straight through the center and we get a screwdriver, the one thing that you need to know is that as we start to tighten this valve up, it will move the inside. Now, don't change anything inside of here. Don't mess around with the inside of the valve, but hopefully you can see as I tighten this up, this red dial and the green little marker there will start to move, as we can see now. Now, in which case, these are now screwed together, but we need to put the knob back into the actual head of the valve itself. Now, because as we tighten this up, that has moved, this knob will not go back into here in mid position. So we need to turn it to where the inside of the head is now, and that will then drop in place, and with a little bit of pressure you can push it down, and we should hear a very reassuring click to say that those have joined together. Now, this is not finished. Hopefully you can see that there's a red line all the way around the actual dial of the valve itself. And people think that that is now complete, because there was that very reassuring click that we talked about before, and you can actually lift up the full weight of the brass valve itself by the knob. So it is very secure in there, as you can see. But if you can see this red ring around the dial, that is not in far enough. And we need to turn it back to the mid position to engage the head to the body. In which case, we're going to turn that round now. And as we get back to mid position, you can see that this will drop in place. That has now joined the body and the head together, and this is locked in place, so the actual motor inside of here will move the inside of the valve. Now, the only person that can mess this valve up and mess this configuration up is the electrician if he gets a hold of the head and he wires it up and turns the power on before you have fitted the head and the body together. So I would highly recommend doing this before the electrician gets a hold of it. If the electrician does get a hold of it, it's not a problem. We'll show you what to do and we'll show you what happens if the electrician turns power on to the actual valve itself. So when the electrician wires this up, we've got 3 wires from the actual valve itself. We've got a black, a blue and a brown. Now the brown and blue are just very simply alive and neutral to the actual valve itself, and the black is the switch wire that moves this from central heating to hot water. Now we said in one of the previous videos and on the level 2 training that this black wire as default, it will be in central heating mode. So you'll get 0 volts down this black wire to tell us that we are in central heating mode. At the end of the day, hot water is an optional extra. You are adding a cylinder to the system. So it's 0 volts down this black wire for central heating and 230 volts down this black wire for hot water. And these wire up in order: the black wire to X to M pin 12, the blue wire to pin 13, and the brown wire to X to M pin 14A. And that's very important that it's in 14A, not 14. So 12, 13 and 14A. As standard out of the box, if the electrician does turn the power on, this will automatically move to central heating mode, because at this point you haven't been through the controls and we haven't told the unit that it has got a central heating cylinder connected to it. So we're always going to move across to central heating mode. And with this valve, when it moves across to central heating mode, it will move 45 degrees clockwise as long as none of the jumpers have been changed inside, which they shouldn't have been for the simplistic method. In which case, it's really simple. We start off with this in the mid position because this started in the mid position, and if this has moved 45 degrees clockwise, the line on the castle over here, we're very simply going to move that 45 degrees clockwise so that it is pointing to the circle. From there, we're going to put the 2 together as we did before, screw the 2 together, and that is it, job done. So as we've said, there are 4 ways that we can fit this valve. The most important thing, and I make no apologies for repeating it, is that you cannot take the flow into the branch. Or the easy way to remember it is that's a circle, so no flow into the O. We have the simple way here, where the flow is into the triangle, circle for cylinder or for hot water, and square for radiators for heating. We could actually swap the hot water and the heating around, and that is perfectly acceptable with this valve, but you may need to change the jumpers in the head, in which case we could still have the flow into the triangle, we could have the circle to heating, and we could have the square to hot water. So there's 2 ways that we can fit this valve. We could actually completely change the flow and put the flow into the square. We could have the heating into the circle and the hot water into the triangle, and that's the 3rd way that we can fit this valve. Finally, we could still take the flow into the square, we could have the hot water out of the circle, and we could have the triangle as our central heating. But as we've said, the most important thing, guys, this is an absolute no-go. The valve will only spin through 90 degrees, it will not spin through 180 degrees, so you cannot put the flow into the branch. That's the only thing we can't do. In which case, if we haven't fitted it to the simplified method and we have swapped the heating and the hot water round, then we need to look at the inside of the valve. And the first thing that we need to think about is this line on the castle here and what that actually represents. So if you have a look down the actual valve itself, that line on the castle signifies which port inside of the valve is closed. And this is really important because most people think that this line points to where the flow is going to go, but that is not the case. This line points to whichever port is closed. Now if I turn this round to the square, you will see that that is now opening up. So we have flow into the valve, and then the heating is open in this case, but the hot water is closed. Now we said with the head that we need to make sure that it is in central heating mode, in which case the easiest way to do that is to look at the wires on the actual head itself. So this black wire, we've already said, is the switch wire, and we should be getting 0 volts on this wire for central heating mode. In which case, we can test this black wire with a multimeter and make sure to earth that we've got 0 volts. Or the easiest way to ensure that this is definitely in central heating mode is to turn the power off, disconnect this black wire from pin 12, and then we know and guarantee that this head will move into central heating operation. From there, if we know that this head is going to be in central heating operation, we can then set the valve up for central heating operation as well and make sure that they are in the same position before we put them together. So in this orientation, we need to make sure that the flow can come through the triangle and go out to the circle, which is our heating mode, and we need to block the hot water. So the line on the castle needs to be pointing to the hot water for us to be in heating mode. From there, we need to think which way this line needs to spin for us to move from central heating to hot water. And in this case, the line on the castle would need to spin clockwise to heating, and that will then block the heating and allow the water to come through to the hot water. So we've figured out that this needs to spin clockwise from central heating to hot water. So we're going to get the head and we're going to take the dial or the knob off the top. And there is a little torque screw in the side of the valve here. We need to undo this with a torque screwdriver, and then from the screw side we're going to lift the actual head of the valve off. Inside here there's a little PCB and there are some jumpers inside. Now these jumpers as standard are in the vertical position, and when you look inside we can see on the left hand side here, from my point of view, we can see a little red resistor, and underneath that red resistor is a little drawing of what those jumpers actually mean. Now if those jumpers are fitted vertically onto the 4 pins inside of here, then the valve will spin anti-clockwise in between central heating and hot water. If these are fitted horizontally, it shows you that the valve will move clockwise from central heating to hot water. In which case, we need to take these jumpers off these pins, and they are quite fiddly, so please be careful that you don't drop them. Change them round to horizontally so that they bridge the 4 pins horizontally, and then we need to put the head back together. So there are some little hinges here. Slot these into the right hand side of the valve and push it down. From there, screw this back, and please make sure that when you're doing this process you don't change or mess around with any of the bits inside. And then once that has been screwed down, we're going to put the cap back onto the valve itself. From there, we're going to turn the power back on. Please do not do any of this with the power onto the valve itself. Those jumpers are very live, as is the wiring inside of here. This black wire should still be disconnected, or it should still have 0 volts onto the black wire itself. In which case, this head will now move to the new central heating position, and it will then move clockwise from central heating to hot water. in which case we know that the head is going to spin the right way from central heating to hot water. We know that the body has been set up the right way, and we can join the two together, and that is the valve completed in this scenario. So we now have a second scenario, and I'm not going to go through all of the scenarios because the principle is exactly the same. But in this scenario, we've got the flow going into the square, we've got our rads or our heating going into the circle, and we've got the triangle being the hot water. In which case, we're going to do exactly the same again, and we are going to check the head and make sure that it is in heating mode. In which case, we want to make sure that we've got 0 volts on that black wire, or the easiest thing to do, as we've said before, is turn the power off to the unit and then disconnect that black wire. From here, if we know that this is the scenario that it's been fitted in, we need to check that the body is in central heating mode. In which case, this line on the castle points to whatever we are blocking, and if we want it in central heating mode, that means that it needs to be blocking the hot water. So we're going to point the line on the castle over here to the triangle so that it's blocking the hot water, and the flow can come into the square here and go out the circle to the central heating. We now know that the body itself is in central heating mode, and we need to figure out which way it will spin from central heating mode into hot water. In which case, if we are now blocking the hot water, this valve would need to spin anti-clockwise to move into hot water mode, because in hot water mode, we're going to be blocking the central heating. So now that we've figured out that it needs to spin anti-clockwise, we need to look at the head again. In which case, the same as before, we're going to unscrew from this side, take the cap off, and lift from the screw side up and take the head off. As we've said previously, try not to move anything on these. I find sticking your thumb over the top while you're trying to change the jumpers does help. And we can look on the side. It says that in the vertical position that the jumpers will spin anti-clockwise. So we're going to take these jumpers off, and they are, as we said, very, very small, guys. If I take them off here, you can see how small they actually are. There's one off there just to show you. We're going to turn them into the vertical position so that it's bridging those pins vertically, put the head back together and join it onto the body, and that is that valve now sorted for that orientation. Using these steps, we can sort out any orientation of the valve. So always disconnect the black wire, and then we know that this valve is in central heating mode. From there, point the line on the castle to the hot water port, because the line on the castle points to whatever is blocked. Once we know that it's in hot water mode, we need to figure out which way the valve will spin from central heating mode into hot water, and that means that the line on the castle will be blocking the central heating mode and allowing the water through the port into the hot water side. Once we've figured out which way the valve will need to spin, change the jumpers, put the head back together. Turn the power on, the head will move to wherever it needs to be, and once it has moved into position, join the two back together and you're good to go. Thanks for listening, guys. I hope that's been helpful to you, and we'll speak to you soon.